Okay, I'm going to talk about the counting principle. I'm going to give it to you maybe in simpler terms than the book does. So let's look at two events. So we're doing multi-stage. Something like toss two coins. Here's what the counting principle says. You look at event A and the total outcomes there. You look at event B and the total outcomes there. Which in our case is 2 and 2. And here's what the counting principle says to do. With a multi-stage event, you multiply these outcomes together. This will give you the total number of outcomes in the multi-stage. So here's what I do. I just make two dashes. I look at the first event, I look at the second. So when I toss the first coin, there's 2 outcomes. Toss the second, there's 2. I get 4. So not only can this be 2 events, it can be a bunch of events. So let's look at tossing 3 coins. We know that we got 8 total outcomes last time, because there are 3 events, 2 ways for the first, 2 second, 2 third, is 8. We rolled 2 dice. Roll 1, roll 2. 6 ways for the first to occur, 6 for the second. I got 36 total outcomes. So let's just try another example of this. Suppose we're taking a quiz. 3 true-false questions and 4 multiple choice. And each multiple choice question, let's say, has 5 answers. So my question would be, how many total ways can we guess on this thing? Drummer just answered it. Okay, I've got 3 true false. So I simply do this. I got those 3. I have 4 multiple choice. I know I'm going to multiply them all together. Well, the number of ways to answer true false, there's 2 outcomes for each of these. These are the true false. Multiply them together. Here's the multiple choice. For each one of those, there's 5 possible outcomes that I could guess. I'm going to multiply these together. And if you remember exponents, that's 2 to the 3rd times 5 to the 4th. If somebody had a calculator handy. Well, there's only 8,000 ways this could be answered. Wait. Sorry, I got ahead of myself. 5,000. And no, I'm not redoing the video for that mistake. Get used to it. So, if I asked you the probability that you could guess and get them all right, hate to burst your bubble. There's only one way you can get them all right. There's 5,000 ways, so that's a small probability. Okay, I'm going to finish this video by looking at with and without replacement. With replacement basically says you put stuff back. Just think of putting things back in the hat. They can be rechosen or reselected or reused or something. Without replacement, just the opposite. They're not put back. So, one of the ways to do this is the book looks at a horse race with 8 horses. And it asks how many ways can they finish first, second, and third? Okay, this is, without replacement. I know somebody caught that. But I got 3 slots. First place, second, and third. So the reason this is without replacement, because there's 8 ways they can finish first. But some horse has to finish first, so there's only 7 ways for second. And now a horse has finished first and second, so now there's only 6 ways for third. So that's the total number of outcomes we can have, which is 336. Okay, I'm going to finish with example 6. Well, we've got the letters A, B, C, D, and E. So we have these letters. How many 4-letter groups can be made A letter can be used more than once. Okay, I'm doing 4 things here. So I'm just going to put my 4 slots out here. How many choices for the first? Well, I can choose any of the 5, so there's 5. Okay, I can use them more than once, so this is with replacement. I'm putting them back in. So there's 5 choices for each of these as well. That's 5 to the 4th. That's 625. Okay, so now the second one is same thing if a letter can be used only once. Okay, this is without replacement. We're not putting them back. Let's see how it affects our count. Hopefully you kind of see this like the horse race. There's 5 choices for the first, but I used one of the letters. I didn't put it back, so now there's only 4 choices for the second, 3, and 2. Now there's only 120 total outcomes. So I'm going to demonstrate this with and without replacement in a more familiar vein maybe. And we're going to do this a lot in probability. Simple deck of cards. Now I have 52 cards. So if I draw one, the 2 of spades, if I put it back, it can be selected again. I still have 52 choices. But now what if I draw one? Hey, the ace of spades, I'm a winner. And I don't put it back. See how that affects this? Now there's 51 choices. If I draw another one, 3 diamonds, don't put it back. Now my number of choices is down to 50. So with and without replacement is kind of a big deal in counting and in probability. See you next time.